Welcome, PyData San Francisco, very cool. So let's talk about some machine learning. I am Randall Shane, and this is Closing the Machine Learning Loop in Python. So let's do the abstract. Let me jump to the abstract of the abstract, which is very abstract. This is about how to assimilate machine learning into your architecture/code. We have a lot of things that run these days that are still waterfall method, which means some data comes in, you do some stuff, you spit some things out, you're done. That is not a feedback loop. That is not how machine learning works. So let's kind of get through it a little bit. We have to include this in our information. We have to develop a feedback loop into the architecture and code of what we're actually using. Who am I? Why do I preach this? You're welcome to stalk me on LinkedIn or Twitter or any of those. I stopped giving my email out because it gets followed by like 7,000 recruiter calls of, take this job in Wisconsin. No. So, I've been doing this a long time. I got about 20 years experience. Unfortunately, I'm getting old, but I used to hunt down cheaters on the stock exchange for a long time, which is fun at 1 billion trades a day to try to find people that are putting across violations. That's always a really neat pattern matching activity. But jumped to data science as it became a thing a few years ago. I've done 4 startups, 3 sold, 1 after I left, 1 catastrophically imploded at the 91st day. It was awesome. When they started building a boxing gym with VC funds, I was like, this is going to be great. It was fantastic. All right, so that's me. So I am the current data scientist for bodybuilding.com. We are located in Boise, Idaho. You wouldn't like it. There's nothing there. Don't come there. I tell everyone that. It's actually a great place. It's a good company to work with. We're like 31 million uniques a month, so we have a pretty significant audience. We have a combination content and e-commerce play, so it's very interesting. I see a lot of weightlifters in the crowd, so if you are a weight piler, marathon runner, bicyclist, health and fitness, we have, you name it, we have it for you. How can I get you into this supplement today? But the reality is we have a very wide site. The difficulty of our site is, honestly, it was built in like 2004. So it's built on a very older e-commerce model, which is okay, but it doesn't fit today's model of a much more personalized experience. Plus, the width of that site is very different. If you come in and you are a marathon runner and the first thing you see is Von Moger, who is a dude who's so big he looks like he ate another dude, you're like, this is not for me. But the reality is we have a lot of marathon stuff. So how do I get things to you in a personalized way? We do that with machine learning. We do that by closing the feedback loop. All right. Here's my little agenda. We're going to do a what section and a how section, and then we'll walk through a little code afterwards. I'm going to walk through an example as we do this, so it's a little bit more tangible. The example I want to use here is gender inference modeling. It is very important in health and fitness, whether you are male or female. There are significant differences between the gender. So let me just get this out of the way right now. Women work twice as hard for half the result. Period. That is what we find, and it is what we find in data consistently. So all you dudes who are like, oh, I can lose 10 pounds in a week. Yeah, of course you can. It's very different for other people, and that changes as you age. So it's interesting to see the correlations, and it's interesting to see what's there. From my standpoint, I know that the base level of personalization is to know your gender. If I know your gender, I can start to get you to the right place. Next, I need to know your goal. So are you trying to gain weight? Are you trying to lose weight? And that's actually really easy. There are 6 women on the planet that are gaining weight. All the rest of them are losing. For men, you're gaining, you're going to get huge until you're 31, and then you're on the lose weight category. So again, a few exceptions, but that's just generally how it works. Health and fitness is hilarious. It's a hilarious thing to work in. It's just, there's so much really good stuff. And I work with a lot of really smart people, and I work with a lot of bros that are like, they flex all day long. It's fantastic. All right. The what section. So what is machine learning? There's a bunch of different definitions out there. I kind of like this one, and I put my little credit down here. I got it off Tech Target. Essentially, it is any code system that self-improves. Let's see if you can read the whole long slide. But essentially, if you are writing code that improves itself, you are writing an artificial intelligence or a machine learning system. You're not writing Skynet, but it might get better at certain things. So, example. This starts our example. I want to infer your gender, okay? The more you visit the site, the more I collect information, which means the better job I can do inferring your gender. Once I know for sure, if you self-select, now you can become part of the training set that says, you are male, you visit these things. You are female, you visit these things. Now I can use it as the training set. So I can kind of use both sides of it. If I know, great, you're part of training the algorithm. If I don't know, you're part of working the algorithm. All right, more of the what. What does this mean for us? Look, the waterfall days are over. I mean, the reality is we need to be smarter. Everything has to operate at scale these days, and scale is usually fairly significant. The reality of that is we just have to get away from that waterfall model. So the more that we can use the output of information that we have, and we can use activity that is generated, you can call it crowdsource, you can call it UGC, user-generated content. I think there's 5,000 algorithms for this stuff, or acronyms for this stuff. You can use that to help make your code smarter. That's the whole point. We want to use that information back in. We have to think of every operation we are performing as more of an opportunity for our machines to pool information and gain knowledge. So it's a little change from the if you've been writing code for a while, the original sort of application developer is like, let's just make it work. It's like, yeah, that's not enough. So we have to keep track. Look, part of that keeping track is integrating things like metric systems, knowing what you're looking for, trying to get that information out the back end. So your activity stream, again, consistent with your gender. I collect that. It helps me determine who you are. If I already know who you are, then you're the other side of that equation. It helps me predict who somebody else is. All right, the last of the what section. We'll say what again. Anyone? Pulp Fiction reference? No. Okay, cool. All right, feedback loops, a circular referral of information. Output is used as a portion of the input. Old days, I think I've droned on enough about that. So I want to collect this activity until I can confirm gender. So if you self-select, you set a goal, I can confirm it, great, now you're part of the training set. But the other side of that is I can also do this if I know that the probability of your male gender is 95% or the probability of your female gender is 93%, I'm probably close enough that I can slide you over into that category. At 31 million people a month, it's difficult to do everyone over and over and over again. The fortunate side is we have a fair retention rate, so the people that I already know, I really don't have to reclassify them. What this does is it reduces the load on how much I have to compute and how much data I have to have in there. So now I can be a little bit smarter about the things that I take in. All right, I think that's the end of our what section. The how. You have to plan for improvement. So in the architecture of the way that these things are built, you have to think through, how do I want this information to work for me? What do I want to do? How do I want to design my feedback loop? So it needs to be designed, and it needs to be designed as a portion of it. One of the big things, I always use a centralized repository for information. So with that said, is it possibly redundant data? Do I potentially have information that I have on other people, other places? Yes, I absolutely, utterly do. But I always put them in a single repository where I can get to the information quickly and easily. I've kind of moved away from, I've moved very much away from using relational databases in production information and basically my production environments. So I do almost everything NoSQL, or I cache it, or I do Redis or Hadoop or something like that. I use a lot of Mongo. I use a lot of Mongo because it's free and it's cheap, read free, and I like it. It's easy to use, it's easy to change, and the nice part about Mongo too is it reduces that semantic dissonance. If you have relational database and it's highly normalized, it's very difficult to look at the base level tables that build and build and build back up this tree to come up with information and see correlations between two base tables that are two normalizations away. It's hard for the human mind to grasp that. In Mongo, in a large table environment and something like that, the information is right next to each other. I have tripped over more really good things in Mongo than I would ever have found in a relational database. I mean, I'm super smart and everything's in my head, and of course I can get it all immediately. Yeah, now I've tripped over a lot of really good stuff. That's humor. If I have to tell you guys that's humor, this is going to be a long session. All right. So think through how to be analyzed. I mean, think of your information. Think through how you want to see this stuff come in. And think of our example. So our example here is pretty simple. Like, I need to have site activity, and I need to know like which portions of the site that you're viewing. Are you looking at transformation stories? Are you looking at cardio? Are you looking at shoulder rehab? Like, the site sections are very important. So think through those pieces of the information and plan for it. Plan the structure and architecture and code that you have in a way that makes that make sense. The curse of dimensionality. I love this. Can you get way too much information? Yes, absolutely. I do not need to track that you are in any one of 25,000 different articles that we have on the site. And we have a great content team and they publish like crazy. But I literally cannot have a table that is 25,000 columns wide as my indicator table. But what is important? Site section. It's important to me what site section that you're in. So I can do some aggregations in that way. Try to limit things. The other thing too is I try to limit activity on a 120-day basis. To me, if you have not been back to our site, / you haven't been hitting the gym or working out for 120 days, you are starting again. So if you think you're going to go back in the gym and you're going to pick up where you left off, you're not. You're starting again. But that's realistic. And it works very well for us. It's a very tangible thing. It also limits the amount of data that I have to have. So I start to solve some of that bulk and some of that dimensionality problem. Real-time versus batched. So some of these choices get made for you. For example, we have a data warehouse, and our data warehouse collects web tracking information, and we have all these things that we track, and it's all really good, and it comes in once a day. I can't really be real-time using that data capture mechanism on a once-a-day basis. It's just not going to happen. So in some ways, some of that as a decision gets made for you. The other side is think through how much of this do I really need in real time and how much of this can I batch on the back end. Are there hybrid approaches to them? Yes. The example here, and I might be getting ahead of myself, is I segment customers, and the segmentation I have of customers, you fall into about 3,500 categories. It's actually 3,240, but it sounds way too specific. So in those 3,500 categories, what I can do is I can pre-batch the things that should be provided for each category, and I can do it off a chunk of data, and does it change that much each day? Not really. So I can do it at night when the computational speed is not that important. And then I leave the live time to sort of my computation of who you are and what the gender is. And then once I get it, I just pull the batched data out of the table and I can push it forward. So you can stage these things together to bring your computational load down. Makes your scale a bit easier. Capture, monitor metrics effectively. So this is a big thing. It is important to remember whenever we write stuff, we want to keep track of it. Look, I do stuff by the numbers. So to me, I want to try to turn everything into supervised learning. I want to try to turn it into an empirical problem. If I can see numbers that are direct metrics correlated with what I'm doing, I know I'm doing well, I know I'm doing not well. If I make a change and I say, I'm going to make a change in recommended products that I send to you, and then on the long end of the e-commerce conversion funnel, I'll look at the conversion rate and be like, oh, it went up. I did fantastically. There's 25 steps in the process that could have changed. I don't feel like those things are related enough to be able to provide me the kind of feedback that I need. Part of getting that is to design into your code, how do I get back the things that I need immediately? And for me, it is when I am inferring someone's gender and I have them inferred in a table and I have them over a certain percentage, or I just have them inferred and I haven't moved them to the I know who you are, but they self-select, I look at that reconciliation between the two. How accurate have I been on a day's basis in being able to infer that person's gender? And so that helps me from the standpoint of I'm doing better, I'm not doing better, and I monitor it daily. All right, example, site activity. We feed it real time to an indicator table. So some of our site activity, we do real time and stuff to an indicator table. It becomes part of that classification. Again, I do it on site section. I don't do every single article just because of that dimensionality problem. I calculate a score. I know when I hit critical mass. I know what I need to be able to make an inference. If you look at 2 articles, I have no idea. I have no idea whatsoever, because it'll be, there's Von Moger, here's a hot girl, here's a guy eating a refrigerator, and you're at the end, I have no idea who you are. But I know if I get you 6 or 7 steps down the line, and it is a combination of using tools on the site, you've gone through the find a plan wizard, you've looked at some articles here and there, I've reached critical mass, now I know it's worth the computational time to pluck you out of there, do the classification on who you are, and then push back into your session the personalization. So I keep that score calculated, and I keep that as part of what's happening as you're running in the site itself. Once triggered, of course, render classification is rendered, and push the segmentation back in, and I calculate that percentage of accuracy. That's my metric on this. Shoot. I have thought of using a Markov chain. I actually don't use that. What I do is I do it on a really simple basis. I effectively add that information to, I have your, essentially your key in the table, and I add that information into the table, and I know once I pass 7 events, I can get you.
And you do feature extraction from that?
Yep.
Okay.
Yeah.
Is there any plan or any kind of the road ahead to do something more intelligent than basic feature extraction?
Yes, it would be very nice. Yeah, absolutely. I like the Markov chain idea, where you can kind of change that state and put people into different things. But it's interesting. I mean, some of that really works at scale, and some of it doesn't. So we have to, 31 million people a month is a lot to work with. So we have issues sometimes with keeping things running on a smart enough basis, fast enough.
And to be fair, you probably get a lot of randomness in that too.
Oh, huge. Yeah, hugely. Hugely. All right, more of the how. I will say this. Speed is not as important as efficiency. So a lot of our site, and I do I have a little engine, it's called GAIN. It is the Goal Achievement Intelligence Network. Get it? GAIN, bodybuilding, making gains. All right, so most of our site is Java site, and I always love the Java guys that are like, oh, Python's like writing in pseudocode. Yeah, it is. That's why I like it. And so it makes the complicated things simple. Efficiency is very important. So it's more important to be efficient in your design than it is to try to brute force through a whole bunch of speed. Do I need to run at the speed of C? No, I don't. It's perfectly fine. Fast database storage. So again, I like Mongo. I cache stuff. I use Redis quite a bit too. Redis is nice and easy. Anybody a Redis user? Yeah, Redis is just, I know there's other stuff out there, but it's just the easiest thing in the world to use. It's so simple. So sticks in memory very fast. Queues, we have ActiveMQ, which is a very good little program. There's a lot of good queuing stuff in there. And is it me, or is the Celery library suddenly like, I'm here, it's Celery. Has that been around for a while? It's like in the last year, I think I've seen it 24 times. So that's a good little piece of machinery. If you don't use that for workers, that's great. That's better than trying to write multi-process stuff and trick it in yourself. So Celery works really well. Reasonability filtering. So try to use reasonability filtering in the data that you store. The reality is, the first time I sat down at bodybuilding and I dug through our data warehouse and I pulled out a whole bunch of people, there were a ton of 5-year-olds and there were a ton of 110-year-olds. And I was like, wow, we have a pretty diverse audience. And I was surprised at how many people under the age of 7 had a credit card. I did not realize that was a trend in the US, but I was like, oh, that's very interesting. So that kind of stuff stored in your data is not helpful. Like, this is just not helpful to have that. So I try to use reasonability filtering in anything that stores. Specifically in your computational tables, you will want a layer, and you will want to abstract that layer and pull all the sort of junk out as much as you possibly can. Don't over-collect, don't over-compute. Hard to do the first time, easier to do 90 days down the road. But that's kind of the process. So that's definitely kind of the process. You try to get to that sort of tuned point where you have exactly what you need, but not more. Knowing computation is going to be fruitful, I mean, that's just a matter of figuring it out. It's just a matter of, you model it, you put it together. I prototype in R, and I do all my production stuff in Python. And I like R, but I once put a recommendation engine in that ran in R, and I will never do that again. So I love it to prototype. I love the granularity of it, but I'm kind of a big Python fan for production stuff. So it had to be plugged into an Oracle stack, and this is before Oracle included it in their actual interpreter in Oracle itself. And so it had to do this crazy sort of pull information in from tables, do its thing, write them out to a CSV, and then they would pick the CSV back up and write it in. And I was like, what? This could only be worse if I was FTPing it somewhere. So it's just, some of these things are process. It's funny too. Worked at smaller startups, and I like the smaller environment. I like to build very aggressively, and I like to make changes as needed, and it's very different when you work for a larger company. And it's nice to have the scale of a larger company, and it's nice to be at startups that grow up a little bit, and you're like, hey, I'm going to get paid next week. But then you get to that point where you're kind of like, I can't just on the fly make a whole bunch of changes. And so it becomes a little bit different. I think habit. I think habit is the answer to that. So yeah, I just generally prototype in R. I feel like in some ways I have more granularity of control on some of the algorithms in R, although I'm not sure with the newer versions of scikit-learn if that's really true anymore. So my answer is habit. Engineer the feedback loop into the system and implement pre-calculated lookups. That's that whole 3,500 segments. If you're in segment, you're 28-year-old male gaining weight, you're a weight piler. Great, here's a whole bunch of things you should do. Here's social people you should hook up with, articles you should read, supplements you should look at, workouts you should do, etc. So pre-batching that makes it a lot easier. Pretty simple example. We're collecting the events, we're adding it to the indicator table. Once I hit critical mass, I go ahead and actually do that personalization, and then it just keeps going to repeat the process until my interpretation of your gender gets above a certain level. And once it's over a certain percentage level, I pretty much know. Once we're over 88%, I think I'm there.
So what's your response time like? So let's say I come to your site,
Mm-hmm.
and right now I'm clicking on 2 pages. For another half an hour, I'm now clicking on 10 more.
Mm-hmm.
You're monitoring that in real time, and then once you've got your threshold, like 10 events,
Mm-hmm.
then how long before the male or female signal gets pushed back into the session?
Almost instant. It's almost instant. So after I have the 7th event, it runs the computation, usually runs in milliseconds, and then I just push it back out, I push it into your session, and on the next update of content that comes out, which is just generally next page, it should be there. The second option is you've self-selected. I self-select, I add you back to the training set. Okay. You get the idea. And this is another piece of how I try to manage that scale. Once I know you, once you've self-selected or I've got over that 88% number and I add you back into something else, I still track your activity and we still track what happens, and I use that as part of the training set, but I don't need to track that live time anymore. I then let that flow through the long process, and it goes through the regular web tracking, and it goes into the warehouse, and I pluck it out of the warehouse, and it's the next day kind of deal. Fine, but I already know who you are, so it's not critical for me to get to that point. So I move it to more of a passive collection versus that off the bat to try to get you the right spot. And that's my active collection. All right. A little more of the how. So the architecture, code section. Test set, training set to evaluate accuracy. Again, I do try to make everything supervised learning as much as I can. So once I have it that way, I have some idea of, I have a number I can focus on and I can actually work with. If it's empirical, it makes it a lot easier. I look for outliers during prototyping. It helps me to kind of clip things off. You know, there's a number of different ways to do this. There's inferential statistics, there's a couple great outliers libraries out there. One of the really simple ones that I like is 2 or 3 times the standard deviation from the mean. So, and that's my little standard deviation graph. So you're really just kind of cutting off 0.3%, maybe you're cutting off 4%. It depends on how dirty your data is. I'll be honest, our data is, we have so much of it. So I use 2 at bodybuilding. I've used 3 other places. That's a really simple way to just kind of get the highs and lows out. Stage your data categorically and use appropriately. And this in our example is a lot of that using site section. Try to use those site sections appropriately. I try to avoid grain of sand size of Jupiter. This person read 2 articles. This person read 95 articles. Fine, but oftentimes I don't like to see that kind of variance in my data. So I just use a log scale, just the Richter scale. Just put it on log 10, it'll bring it down, and it'll bring everything to a much more normalized way to work with. Shoot.
Do you find that things are generally normally distributed the way that people behave, so you can do the mean and standard deviation approach?
You can. I often have to do this first. So I have to kind of cut some outliers off, and then once the outliers are cut off, you usually get into a fairly decent place. I am also very partial to tree-based methods, and I think they do a better job with more real-time data, just in that way. And so I have a great love of the random forest. It's just so robust. I mean, it doesn't matter like how far off a lot of the stuff is. It still seems to come out pretty consistently. So I use a bunch of. I always try to use multiple methods. So again, I am a huge fan of tree methods, but I will always try to model in a number of different ones. I keep thinking to myself, I'm going to model something in, and I am going to find some obscure method out there, and it's going to be the perfect thing. It never is, and I wind up using random forest like 98% of the time. But the point is that I always in my head is try something else, try something different. If nothing else, then for the experience of trying something different and having the experience of walking through it and see why it does what it does. Method averaging is a really nice thing. Ensemble methods is a nice thing. Population splitting, if you can figure out which populations work better with which methods, that's a nice way to do it. A lot of this has to do with just taking the time to sit down with the information you have, prototype through it, get it running, and then iterate your efforts. The first effort is never perfect. It's like all those people that proclaim that they are these artful programmers and they write these beautifully executed codes the first time and the program is all put together. I do not know any of those programmers, and I am a horrible typist. So when I write stuff, the first time I go to run it, it's like literally I have to go through 25 typing errors. And in my head is like, I should learn to type. I don't think it would help me code better, so I don't. But it's just one of those things. But iterate your efforts. The more you iterate your efforts and the more you go through, the more you start to gain that understanding of this is why this did this. This would work better. This is more appropriate here. And it helps you to kind of make those decisions. Like, should I split my population and use differing algorithms to get there? Lastly, monitor runtime and load metrics. Absolutely. There's a lot of ways to do this. There's a lot of tools for that stuff. There's a lot of third-party tools. There's like Datadog and Zabbix, and there's hundreds of these things out there. I have probably used the same silly little method that I've used for years and years, and it's just a PS utility library. and I just pluck some stuff out of PSUtil and I just jam it into a table, and I can see while things are running what memory looks like, what my computational load looks like, and it makes it really simple. That's an easy one. And then, time it, use asymptotic notation when you write, that kind of thing. All right. Keeping track. Implement metrics to monitor progress. If you do not have metrics in there to monitor progress, you do not know. If while you're going through it, you think to yourself, if I know this item, I will know exactly how this is doing. You should write that item in there. Period. It should be in there. Figure out a way to track it. Get it in. You have to implement metrics. I feel like I'm preaching to the choir. But when I talk to application programmers and they're like, oh, no, we'll put it in afterwards. No, we'll do it now. Let's do it up front. That's much more of a fight in established companies. That's much less of a fight at a startup. There seems to be more of understanding of that. I always design with metrics in mind. I pick 1 to 3. Don't try to be like, I'm going to check 50 things. Don't do that. Don't do that, because what's going to happen is 2 of those things are going to be at odds with each other, and they will be at odds for a differing reason, and then you will doubt one of them. And you will inevitably doubt the one that is important to you. That's just how Murphy's Law works. So pick 1 to 3, try to put them in there. Don't overtrack the stuff. Just get a simple idea of what's happening. Again, direct association is important. Iterate efforts without a doubt, and do it by the numbers. Don't ever feel like it's better. If you feel like it's better, you bumped your head. Don't do that. Put numbers to it. It should be better empirically. Example, very simple, monitoring classification by day. I look at the classification of the training set that's there. I look at the accuracy of confirmed people that are there. So I do the test set training set, and then I look at my test set. I look at people that have self-selected after the point that I've already classified them, and that gives me a decent sense of how I'm doing. Keep calculating over and over again, prototype for your best result, etc. All right. More of the how. Here's what is not important. It is not important to have the same attribute in a table twice, because one of them will tell you what 2 of them will tell you. And I'm shocked at the number of times I look at any analytics, metrics, tracking, any of those systems, I look at data and it's exactly that. It doesn't make any sense to me. So try to get those things, pull those things off. Even if you have individual and unique indicators, if you want to say on these features which ones are really important, a couple ways to find out. Keep prototyping on your information, see what's there. I always look at attribute importance that comes out. And so I'll look at which attributes it sees are very important and which attributes it sees are unimportant. Once I've made a decision as to what to use, if I pull a few of the unimportant ones out, do I still get the same thing? What if I take the most important one out? Then what does it tell me? This is part of the prototype process. This is just kind of part of what I go through and what's there. If you find 2 features that are directly correlated with each other, your correlation value is like 0.88, you can probably just pick one of those. And it depends. If you have 25 columns of information, 25 fields in your indicator table, it's probably not going to make any difference. If you have 150, yeah, it'll probably make a difference. It's probably easier to start paring that down. Use common sense. I mean, some of this stuff just doesn't fit anything. Eliminate duplicates, don't ever track again, prototype with relevant past experience. Okay, so I try to prototype with blocks of data that make sense. For example, in health and fitness, there is huge seasonality. January, everybody's going to get fit. April, everybody's going to get a beach body. November, I'm going to eat. December. Every year without fail. So if I want to prototype on stuff, and I want to prototype in August because I want to get some stuff in and start getting it moving for the January push, pick up January's data from last year. Don't pick up August data from this year. It is completely different. So try to get a relevant data set that's there. Time series decomposition is very helpful in figuring out trend, seasonality, and randomness. We have 3 hugely random days. Black Friday is a huge random day, Cyber Monday is a huge random day, and we have a birthday bash on the founding date of the company every year. And it will literally be this huge, like, random spike in activity and all kinds of stuff. Pull those out. Just pull that stuff out. That's not going to help you. So try to get decent, relevant data. As much as you can use existing tracking, try to. It's kind of nice when something's already plumbed. I think that's about 50-50. Sometimes that works really well, and sometimes that doesn't. One of the things I think a lot of companies suffer from, though, is my 6th point. I want it all. We're going to collect everything. It weakens me. To me, that is an excuse for I have no idea what I'm going to do with this. And I have a couple of my most favorite quotes. I know there's value in that data. We just have to find it. Yeah. That's usually followed by data storage is cheap. Okay, give me your personal credit card. I'm going to put the AWS bill on it. You'll watch backpedaling like there is no tomorrow. Here's what I promote. Turn it all on. Turn every piece of it on. Collect everything you want to collect. And in 90 days, we're going to sit down and look at that information. And when we find in 90 days that you have 1% signal and 99% noise, we're going to turn 99% off of that off, because it's getting ridiculous. I just did some contract work at a company, and they tracked 612 things on each web page. 612 pieces on each page. They had literally billion-line tables in SQL Server. I was like, oh my God, look, that's not even queryable. I don't know what you would do with that. And it was, no, but it's cheap, and we already have the architecture, and blah. Okay, look, you know how much of that was important? There were like 3 metrics that were actually important that they were tracking. It's just over tracking. But we have all this rich data. You only have good data if it's actionable and worth something. You don't have good data if you have a giant puddle that's a mess. So my thing is kind of, let's not collect the mess. 90 days, let's test it out. Let's try to keep what's important. Okay, so non-correlated data types, I drop from my example. I get rid of duplicates. You can permute stuff together. You can streamline, calculate accuracy. Okay, I think I beat all this stuff to death. All right, questions? So far, so good? All right. Training set, test set. Here's how it works. Most of you already know this. For us, we have known customers with genders, no problem. Then we have activity for those people, and that activity forms an indicator table. That in that indicator table, since I already have your gender, I have your known outcome, that's my training table. I can use that to train my classification method. I feel like. Where is it? Cam? Okay. So test set. Portion of the training set, you clip that baby off, and you essentially already know. But if I use my trained algorithm and I apply it to my test set, since I already know, I can see how well my algorithm does against the data I already have. And that's simple training set, test set. That's very, very basic. So that's how we do it. Here's how my feedback loop works in production. You come to the site, perform some stuff, 2 things are happening. Here's where the loop is kind of in. I'm collecting information as it's moving forward. I already have this sort of on-the-side collection of people that I know. The classification's live. I apply that segmentation. You self-select. I get you over a classification line. You get dropped into that sort of passive table that I can use to retrain on the following piece. But it's designed in as part of it. And then once we push that in, we personalize your experience. All right. Let's see some code.
Can I ask you a question?
Sure.
So is part of that you're somehow selling advertising? What is that? Is that what you're doing on the side?
So We're just now putting in an ad stack. Like literally, we have not put an ad stack in before. So we are just getting to that point where we're kind of starting to monetize content. So we have typically been, and it's still true, content is free, the workouts are free, there's a, like, it was built in that day of, oh, we'll build our own social network. So we have like a little social fitness network. That's all that stuff's free. And then the content and articles, we're starting to put advertising on to monetize those. And then we have e-commerce. So we've tons and tons of supplements.
So I guess I'm trying to figure out, is your plan to take this information, you're trying to assess people's gender, for example,
Mm-hmm.
their experience on your site. At that point, is that going to influence how the spaces on your site are going to be laid out to the ad network?
Yes, yes. So what will happen is that inference modeling will push into the DMP, the demand management platform, and then that supplies the segmentation audiences that can come from the programmatic bidding portion of it. So on any of the ad stuff, you have essentially most of the ad companies. We're actually going to use Crux, and they're actually really good. They have a pretty wide cookie that gives interest, age, demographic data, gender, all that kind of stuff. But then you also push in first-party data. So we'll push in the first-party stuff that we know as well. We will eventually sew all that together.
But is it a competitive advantage being able to assess these things instead of the quality of ad you put on?
It is specifically from the standpoint that we have a high volume of customers that come in every month that we don't know who they are. And so while the wider purview of the cookies you get from an ad platform are very useful, oftentimes you cannot pull that information back out and use it first party. So if I wanted to use the ad platform's cookie-based segmentation to do like product recommendations, I would have to essentially serve my products as if I was serving an ad zone. Because you can't sort of pull that. They frown on you pulling stuff backward out of their platform.
I mean, you're treating gender discrimination like a dating process essentially, right? Because that seems to effectively what you do. So you do need targeting of stuff that then you further split test to help determine gender. So for example, like if you know what your gender is because you got a profile of your site, you do your normal process flow. You do a segregated flow in order to put stuff in front of it to determine the gender of the have.
We don't go that far. I mean, we could, but we don't go that far. The one thing we will do is we'll put a pop-up. Hey, sign up for our deals. And we have, deals, % off, free shipping, that kind of stuff. And as part of that, it's give us your email address, give us your gender, give us your goal. And so we'll ask, but we don't go too far with it. We try to do it the right way. Like we really do. We really concentrate on trying to make it not creepy, and we're just trying to get the right stuff in front of you. So
since most of the data that you're collecting is from clicks on your site that are questions, is there any data that exists that's, let's say, like a factor that you can't collect, that you don't know what it is, like a dimension to the data cloud that you have, that you cannot get directly from the data that you're collecting on the site?
I would say yes. So we have a combination of, we ask questions, and then there's things like widgets on the site that you go through, like if you're going through find a plan to figure out what workout plan you should do. And there are other things that we infer, like if you're buying all female-based products, and then there's site activity. There are things that we don't know where we try to infer, and intent is a big one. So you can look at someone who is looking at like shoulder or knee recovery, and they're looking at a lot of recovery type things, but are you looking at this because you've had an injury? Are you looking at this because you have like weak knees? Are you looking at this because you're a marathon runner? Like how does this sort of fit? So the question becomes, do we have a recovery category, or is it a subcomponent of something else? And there are compelling stories both ways.
How do you determine those factors?
How do we determine, like, whether they're in a...
No, like, say in the first year of operating your site, that there was a category called, needs recovery, looking for recovery? How do you infer that? Not even knowing that that was a dimension to begin with.
Site section, and you can see it over and over when you look at things like tagged articles. And we tagged articles, and we tagged like the use of supplements or that kind of thing. So I know if you're taking a lot of like chicken cartilage and glucosamine and you're reading shoulder recovery articles, that's very much in this sort of genre of it. So it becomes inferred from other data that's there. Does that answer your question?
Well, it just seems like there had to be a human who looked at it and made a decision, like, maybe using some dimensional reduction or something like that, and you're like, oh, this new factor, this is recovery, because I know what people do, I can figure it out. So you need a human to look at that and figure that out.
Yeah, that's part of prototyping. A lot of this comes out as we prototype data. It's hard to get a machine to interpret all those things. Cool. Any other questions? All right. Should we watch some code run? That's always fun. All right. So here's my here's just a little clip of my model. Essentially, all right. So I start to run through. I got my read time. I do a little transform and save. Part of that transform and save routine is coming up with things that are important, like it's interesting that refer actually. Oh. Well, that's not going to work. Hang on. Okay, that's a weird thing. Hey, there we go. All right. So, we run through, I do a little read of my information, I do my little transform and save. Some of that transformation also is just getting categorical information off things like refer, site section. We kind of turn it into a number. Some of those numbers are ordinal, some of those numbers are just indicator numbers that are there. And then we start to run through the classification. I split my training and test set, so it's about 65,000. So yeah, it's about 45 and 20, about 70-30 is usually what I use. When there are arguments to other numbers, use what you're comfortable with. I'm going to run 3 different algorithms here. Random forest, gradient descent, and nearest neighbor. So trains that algorithm up in just about 45 seconds. And there's my test set. I looped through my test set, and classification time on that took about 20 seconds. And then I grade myself. And so random forest about 79%, then 78 on nearest neighbor, 70 on gradient descent. If I method average them, I see that brings it down a little bit. It may be that certain audiences are specifically better under one algorithm than another, but that's generally how I run through it. And my code looks like, there we go. Okay, so this is PyMongo, and then these are coming out of the scikit-learn library. There's my connection stuff. Here's my little lookup on refer, and here's my little prep. So I go through the different site sections that we have, do a little cleaning out, and let's see, a little validity check to make sure we have information. Here's my transformation, and then I do a little decider on test or train. Once decided, I run through my classification. And so it runs through, trains my algorithms. You notice I have attribute importance for random forest commented out at the moment. I generally put that back in. I think that's probably an argument for prototyping with Python also. And then We just kind of run through, I do my probabilities and my predictions, and then I blend that stuff together so I have a little, my little method average in there. And then I just grade myself and just print it out at the bottom. Thank you. I appreciate it.